Okay, this is a center of mass problem. And normally, center of mass is easy if you just have like a big geometric shape, right? So like for each of these little plates that are welded together, each of these have a center of mass right in the middle of the plate, right? In the geometric center. But I've welded these four plates together, and that's going to make the center of mass not be in the exact middle of these plates, right? If they all had the same weight or the same mass, then the center of mass of this big combination would all be in the middle, right? But it's not going to be. So if you have weird weight distributions like this, the formula to get the center of gravity of one of the axes, right? So I need to find the x-coordinate and the y-coordinate, right? And so the way to do this, the x-coordinate, the way I'm going to do this, the x-coordinate for the center of gravity is going to be equal to the sum of all the pieces, right? The weight of each one times the x location of each one, divided by the sum of all the weights. It's kind of like a weighted average, right? Okay, so you're looking at this like, what in the hell? You're writing Greek, right? So let's look at what this means. Basically, first we got to decide where the x components of the centers of gravity are, right? So each of these little blocks has a center of mass that's right in the middle, right? So see how these two line up right there? And these two line up right there? So the x components of the center of mass of these two things are here and here, right? So if this distance right there is 2a, that means that each of these little parts is 1/2 a, right? So if this is 2a, right, let me show you what I mean. So if this is 2a right here, that means right here is a, which means this is a over 2, and this is 3a over 2, or 1.5 a, right? Those are the x components. And then w is just the weight. So this little summation basically means I'm taking the sum of each w times its x component divided by the sum of all the w's. Okay? So let's look at how to do the x component, right? So each of these, I'm going to sum on the numerator, I'm going to sum up the weight times its x component, right? So we're going to go through, there's 4 of these I need to get. So my x center of gravity is going to be, I'm going to call, let's make this easy. I'm going to call this W1. I'm going to call this one W2. I'm going to call this one W3. And I'm going to call this one W4. Just to make it easier with your numbers. So instead of using my numbers, I'm using a variable, right? So 80 is weight 1, 80 is weight 2, 30 is weight 3, 60 is weight 4. So I'm basically going to go through and just multiply each one of these by where its x center of gravity component is at, either a over 2 or 3 over 2, right? And I'm just summing them up. That's what that means. So here I go. So I've got my numerator now. So if you notice what I did, W1 times a over 2, its x component is a over 2. W2 is at 3a over 2, right? So I put that one over here. I did my a over 2's together and my 3a over 2's together. So these two, W1 and W3, both get multiplied by a over 2. And these two, 2 and 4, they're further away, so they're getting multiplied by 3a over 2. Okay, and then underneath, I'm just taking the sum of all the w's. So I'm going to add up all those things. So it's basically just going to be weight 1 plus weight 2 plus weight 3 plus weight 4. That little I just means like however many things there. So if there were only 3, I would only have 3 numbers here, right? And that's it. And so I can solve, right? I just got to plug in what W1, W2, W3, and W4 are, right? It's not that complicated. It's basically just doing a weighted average, right? If you've done your grades, how like daily work is 60%, homework is 20%, this is the exact same concept. You're just taking a weighted average, sort of. So that's going to be my x component. And then your y, right? So for part 2, find the y coordinate of the center of gravity. That's the same concept, except now my y equation, my y center of gravity, is still going to be the sum of all the weights, but now I'm going to multiply it by the y part over the sum of all the weights. right? So now, same thing. Let's go look over here. What are my y's? So here's my centers of mass, right? So see how these two line up right there? And again, these two line up right there. And again, right, this goes from 0 to 2a. So that means this is a. So that means here is a over 2. And here's 3a over 2. Right, so it's going to look exactly like it did before, except now I'm looking at it on the y-axis instead of the x-axis, right? So when I do my y center of gravity, right, we'll go through this real fast. I'm going to plug in my y stuff. And that's what y would look like. And so notice it looks really similar to what the x looked like. The only difference is where the 3a's and the a's are. So now weight 1 and weight 2 are both at 3a over 2. They're this far away from the center. And weight 3 and weight 4 are a over 2 away. So the distances, the component distance has changed, but the number hasn't. And so if I wanted to solve the y component, I would just do that too. And so when you get it, it's going to be some multiple of a. All right. So center of gravity, it's just a weighted average, right? Really not that complicated. If you can remember, basically just figure out how to find these distances as a function or as a fraction of 2a or a or whatever it gives you, it's really not that hard.